Right, so positive slope goes in the upwards direction, and negative slope, the line's pointed in the downwards direction, right? So right off the bat, we know whether or not something has a positive or negative slope just by looking at what the graph looks like, right? Or vice versa, if we know that a slope is positive or negative, we know whether the line's going to be going up or down. That's great. Here's the equation of slope and how we figure it out. And so the slope m, we usually represent slope with the letter m, right? Remember that. The slope of a non-vertical line that passes through the points x1, y1, and x2, y2 is given by this equation. And so there's two things written here. There's rise over run, and then there's this equation, y2 minus y1 over x2 minus x1. And so the second version of that, that's what you use when you're given 2 points. If you're given 2 points and you want to know what the slope is, then you plug it into that equation. And it doesn't matter which is y2 and which is y1. You can, in other words, you can do y1 minus y2 over x1 minus x2. As long as you keep them consistent, you can switch it around. The rise over run, that's what you want to use when you're given a graph. So you can count off rise over run if you're given a graph, and we'll look at a couple of both of those. And then once you have the slope and you have a point, we usually write the equation of a line one of 3 ways. So the first, and you know, the name sort of gives you, it tells you all you need to know about what you need for that particular line. So the first type is called point slope form. And it's called point slope form because what you need to write this form is a point and a slope. So you should never be too confused about like how you write that line or what sort of things go into that line, because the name itself tells you what you need. So point slope form, you need a single point and you need the slope. And then you write it in this form. So notice that we have the point x1, y1 and slope m. And you can see that x1 and y1 are going in those 2 positions, and m goes right here. And so these 3 things are numbers. Everything else in that equation, so the 3 things that I'm pointing to are going to be numbers, and then the things that I'm not pointing to are variables. So the y and the x here, those 2 things are going to be variables. And so that one's super easy. If you have a point and a slope, it's like you just put them right into the positions that you need them. You put the points right there, the single point right there, and then you put the slope right there, and then that's it. If you want the slope-intercept form, well, again, the word tells you what you need. So slope-intercept is telling us that we need a slope and a y-intercept in order to write this. And you can see that the slope, m, is right there, and the y-intercept, b, is right there. And so those 2 things that I'm pointing to are numbers, right? And then the things that are not numbers, again, are the variables, y and x. Those 2 things are not numbers. And so this one, in my experience, and the way I learned this stuff, and from working with I don't know how many students on this stuff, this is the one that's usually more familiar to people. Does that sound right? Y equals mx plus b is usually, I feel like, the one you're used to using. I don't know. I am, and I'm seeing a lot of head nods. But just know that point slope is also a version, and it's actually, quite frankly, an easier version to use because you don't need to solve for that b. So if you remember that the y-intercept, you're usually not given the y-intercept. You usually need to figure out what that is. Do you remember how you do that? Do you remember that at all? So the way we usually find b is we plug in a point x and y. So we have our slope, and then we plug in x and y, and then we solve for b. And so I'm just going to make that note here, and I recommend you write this down because I say sometimes, but it's usually all the time. I'll put quotes around that. Quote unquote, sometimes you need to use the slope and a point to solve for the y-intercept. That's the b in the equation. So sometimes, quote unquote, usually all the time you need to do that. And then the last form on this page is called the general form. I always go back and forth about whether or not we even want to talk about it because it's kind of pointless, and quite frankly, the way I think about getting to this equation is just by rewriting one of these equations. So see how this has all of our values are on one side and then it equals 0? If we just take either one of those previous equations and we just get everything over to one side, we just subtract everything over to one side, it would be in the form of a general equation of a line. And so the way I usually think about this one is just rewrite the slope-intercept form to get this form. In other words, it's not a super relevant form. Forms 1 and 2 are usually the ones that you see all the time, and they're the most useful. You may see form 3 occasionally. I don't believe I even put that in the homework at all. I tried to just avoid that form because it's not particularly useful, I feel like. But you should just be aware that it's out there, and so that's why I just keep it on here.
So instead of using that one, you can just use U1
Yeah, so in homework and in tests and things, you'll be asked to use a specific form just to make sure that you understand each one. Like you'll see in the homework, it'll say, write the equation of this line in slope-intercept form or in point-slope form. And you may see one that says write it in the general form, but not usually. And as far as tests, I'm usually pretty flexible about which one you use, but I may want to see that you can use both. Like I may give you a line and say, write the equation of this line in both forms. So you should certainly know how to use at least point-slope form and slope-intercept form and be able to do either one on a problem.
So for rewriting the general equation, with slope-intercept, you would just subtract the y to get it equal to 0?
Yeah, exactly. We could go from slope-intercept to general form by just moving the y over to the other side. Or moving mx and b over to the other side too would also be true. And we'll do that on one of the examples. Other questions right now? And so the last thing I wrote down here is that every non-vertical and non-horizontal line can be written in these forms. And vertical and horizontal lines are what's shown on the next page. So let's flip the next page and just look at those quick before I let you work on some of this stuff. So the first thing on the page is just showing you what vertical and horizontal lines look like. And I know you know what they look like, but just reminding you of what the equation looks like. So if we have a vertical line, that's what this one looks like, right? This one's vertical. Notice that the x value on that line is always x equals 3, right? At every single point on that line, the value is x equals 3. And so that's why if we have a vertical line, we write it in the form of x equals wherever it is on the x-axis. And if we have a horizontal line, the opposite's true. We write y equals, because if you look at this horizontal line here, it's at the point y equals -2, and it's always at the point y equals -2. Right? So if we have a horizontal line, we write y equals, and if we have a vertical line, we write x equals. Again, just because it's always at that one spot, it's either always at y equals something or it's always at x equals, and so we just use one variable to represent those types of lines. If we have parallel lines, the next two things here are parallel versus perpendicular. And so this first thing says, if we have two non-vertical lines that are parallel, that means that they have the same slope, right? So for example, so this is a pictorial representation, and you can see that they're vertical because they are perfectly aligned next to each other and they're never going to cross. And so for example, that these two lines have the same slope. Y equals 1/2 x minus 6, and y minus 1 equals 1/2 x plus 3. So one I wrote in point slope form, and the other one I wrote in slope intercept form. But regardless, we see that they have the same slope. And so we know those two lines are parallel. I don't know what those two lines look like. I'm not graphing them at all. I have no idea what they look like or where they, whether they're above the x-axis or below the x-axis. I'm not thinking about that. All I'm thinking about right now is they have the same slope, and so I know they're going to be parallel. And so the opposite of being parallel is perpendicular, which is what's shown down here. And so two lines are perpendicular if they cross and make a right angle. And so you can see that I'm making a right angle with these two. Not angle. And so if they cross and make a right angle, they're perpendicular. And we know that two slopes are going to be perpendicular if when you multiply them together, you get -1. That's what this says right here. Right? m1 times m2 equals -1 means if you multiply the two slopes, you get -1. And so another way of saying that is that one is the negative reciprocal of the other. And so first of all, I don't know about you, but on my piece of paper, this kind of looks like it's a part of the fraction, but that's a minus sign right there. So make that clear on yours. There should be a minus sign out in front. It's kind of blending into the fraction in it. Right, but there is a minus sign here. I'm just going to write it above. And so, for example, if we get two lines, let's say we had our line 6x minus 10, and we had our line minus 16x plus 30, we can see that these two lines are perpendicular to each other because their slopes are negative reciprocals of each other. And reciprocal means you flip the fraction over, right? So when you flip the fraction of 6 over, it becomes 1/6. And when you flip the fraction 1/6 over, it becomes 6, right? And so those two are reciprocals of each other and negative reciprocals because one's negative and one's positive. So we see that m1 times m2, when we multiply those two slopes together, we get -1, and so that means that these two slopes are perpendicular. Okay. Questions about this stuff before we, I was going to maybe look at one and then turn you loose on your own. But if there's questions about how this stuff works or what I wrote down at this point, by all means, let me know. Anything? Okay, let me just do number 2. And just number 2, because number 2's got a lot of stuff going on, and I think if you see number 2 and it makes sense, you should be able to do the rest of them. So I'm going to do number 2, and then I'm going to turn you loose and see if you can try the other ones here. So number 2 says, let's find the the equation of the line that passes through these 2 points, 2, -5, and -4, 3, and we'll write it in all 3 forms, and we'll graph it. So the first thing we need is a slope, right? Anytime we want the equation of a line, we need a slope. And so let's find out what the slope is, and we're going to use the slope equation. So the slope equation says subtract the y values and then divide that by subtracting the x values. And so I chose to use the -4, 3 point as my x2, y2, but you could switch them too, right? In other words, we could take both the things in the numerator and the denominator and switch them, right? We could do -5, -3, or we could do divided by -2, -4. So we could switch those things around if we wanted to, as long as you switch both of them. Okay, so this slope's going to end up being 8 over -6, or -4/3. So that's our m. Right, so in all the equations on the previous pages, that's going to be our m. Is that okay? And so now we just want to start writing the equation. So for example, I'm going to start with point slope. So point slope, we need a point and a slope. We have both those things. And so I'm going to use this equation, y minus y1 equals m times x minus x1. And so you have two options, right? You could either write, so let me do point slope. Switch colors here. So point slope could be either, if we use the point minus 4, 3, it would be y minus 3 equals minus 4/3 times x plus 4. Or if we use the point 2 comma negative 5, either one will work. We get y plus 5 equals minus 4/3 x minus 2. And both of those are the same line. They look differently, but they're actually representing the same line. Just going through two different points on the same line. Now my question for you real quick is, where did that plus come from? So it looks like when you look at the equation, yeah, this one, it should be y minus y1 and x minus x1, but I've got a plus 4 here and a plus 5. Where did those pluses come from? Why are they not minuses?
Those points were negative.
Yeah, we did a minus. So like the plus 4 came from the minus 4, because we had x minus minus 4. And then the plus 5 came from y minus minus 5. Is everyone okay? And so let's do the slope-intercept form then. So slope-intercept, we need to solve for b. So we have the equation y equals mx plus b, and our m is minus 4/3. And we need to figure out what b is. And what I wrote on the last page is, usually you need to find b by plugging in one of the points. And so I can use either point. I'm going to use 2, negative 5, but you can use the other one if you want. And you plug that in, because that's a x comma y, right? So you use that x comma y and you plug it in there and you find b. So that's going to be minus 5 equals minus 4/3 times 2 plus b. So I just plug that point into the equation. And then that's going to be 8/3, so we'll get b equals minus 5 plus 8/3. So minus 5 becomes 15/3, right? Minus 15/3 plus 8 is minus 7/3. And so this is my b. And so then I just plug it back into the equation and we get my equals minus 4/3 x minus 7/3. So that b went right into the b spot. Alright, and then the last one I'll do here is just write down what the general form is. So as I said before, I think the easiest way to get to the general form is just to rewrite point slope form. Just get everything over to one side. So I'm going to rewrite this. I'm just going to add the 4/3 x and add the 7/3 over, and we'll get y plus 4/3 x plus 7/3 equals 0. And that's the general form. And so that's how you find any three of the equations.
So you got negative 7 over 3 from negative 5 plus 8 over 3.
Yeah, so I plugged the points into the equation. I plugged 2, negative 5 in, and I got this expression. and then 2 times negative 4/3 is 8/3, and so then I added that over to the other side. That's where this came from, the next expression. And then when you add those two together, you'll get minus 7/3, yeah. And then that went right into the B spot, right? That's what we were looking for, and so that's where it went.
So in the general form, should it be minus 7/3?
It was minus, and we got everything over to one side. So I added the 4/3 x and the 7/3 over to the other side to put it in the general equation. So they were negative, and then I added them over to the other, and they came positive. What about graphing it? Let me just graph it quick, and then that'll be it here. So there's a couple ways we can think about this. One way is you just plot 2 points. If you can plot 2 points and then you connect the dots, that's the line, right? So if you have 2 points, like 2, -5, and -4, 3, you can literally just plot them and then connect the dots. And so that's what I'll start with. So let's start with 1, 2, -1, 2, 3, 4, 5. So that might be right here. And then -4, 3. -1, 2, 3, 4. Positive 1, 2, 3. So this could be the point -4, 3, and that would be the point 2, -5. And once we have 2 points in a plane, when you connect the 2 points, it's a line. Alright, so I forgot to bring a ruler here, but this pencil might work. Great. So that's one easy way to do it if you happen to have 2 points. If you don't have 2 points, you'll always have 1 point, right? You need 1 point at least because you're going to find the slope, and usually it gives you 1 point. You usually have 1 point at least. If you have 1 point, what you can do is you go to that point and then you count the slope off, right? So let's say we were just given 2, -5. Forget about, well, let's say we're given -4, 3 actually. Forget about 2, -5. So let's just pretend we had that point. And so we have that point right there. The slope is -4/3. And so we could also count -4/3 off because m equals -4/3 is our rise over run. And so this is like a -4 rise, which means go down 4, and then run 3, to the right 3. So this would be going down 4, 1, 2, 3, 4, and then run 3, 1, 2, 3 would put us right on this line. So our rise over run also gives us that. So if you have 1 point, you can just count the slope off. That'll give you a second point, and then you connect the dots that way. Right? Okay. Any questions about this stuff at all? Feel like you could do some of these now? I'd like to spend, say, let's spend 20 minutes on this stuff. Do as many of them as you can. I've got all the solutions up here, and so I'll come and pass some of these around. You're welcome to check your answers. The solutions are also up on Blackboard. If you have your phone or your computer or something, you're welcome to pull the solutions up there. And we'll spend some time on this, and then we'll come back together and write down the answers. Looking at some of these, but just under the assumption that we may not have enough time to do all of them, I'd like to start with whatever one you want. So, which one of these do you want to see? Which one of these is tripping you up a little bit?
Number 6.
Yeah, let's do number 6. So let's start with number 6. Okay, so if we want to write the equation of this line in all 3 forms, we at least need to know a slope, and we need to know a point, right? And so we can pick both those things off of this graph. We can pick the slope and any 1 point off that graph. So when I'm looking at this, you want to look for like intersection points. So I see it crosses right here. Let me use not red. It crosses right here, and it looks like it also crosses down here. And those also happen to be the intercepts. And so that intercept right there is -4, 0. That's the y-intercept. And then this is the point, I'm sorry, it should be 0, -4, not -4, 0. x is 0, y is minus 4. The other one is the point minus 3, 0. And so the way we get the slope is we count the rise and the run, right? So the rise here is it goes down 1, 2, 3, 4. So if it goes down 4, that is a rise of negative 4 because it went down that many. And then the run is from here to right here, and that's a distance, whoops, I went a little too far, from right there to right there. That's a distance of 1, 2, 3. And so the run is positive 3. And so the slope then, or the m value, is the rise over the run, which is minus 4 over 3. And so now we're most of the way there, because we've got the slope, and we already wrote down a couple points, and so we can use either one of those points for the rest of the stuff. But the slope is the important part. Is the slope okay? Alright, so let me just finish this one. So then point slope, right, it's all in the name. We need a point and we need a slope. I'm going to use the point minus 3, 0. But you can use any of the points on that line, on that graph. Just make sure it crosses one of the intersection points so it's a whole number. But at minus 3, 0, it would be y minus 0 equals the slope times x minus x. And so we could write it as y equals minus 4/3 x plus 3 if we want. That would be a point slope one. If we want to do slope intercept, we already have both those things because we can see what the intercept is. We don't necessarily need to solve for it because we can just look at the graph and see that the intercept is at minus 4. Right? And so we know that it's y equals minus 4/3 x plus b, and b equals minus 4 from the graph. And so we can just get y equals minus 4/3 x minus 4 for that one. And then for the general form, I just add everything over to one side. I usually like to keep things positive. So I just add things over to one side and get y plus 4/3 x plus 4 equals 0. And then you'll see on the page on my solution sheet, what I did was I just got rid of the denominator by multiplying everything by 3. So you don't necessarily have to, but that's why on my piece of paper I have 3y plus 4x plus 12 equals 0. Because I just multiplied everything by 3 to cancel out the common denominator. Right? That was like one of the things from the fraction section. That's how we get rid of a fraction. It's just multiply through by the common denominator. So was that one alright for the folks who wanted to see that? Was it the general form that was maybe a little confusing? Yeah, I thought that one might be. But again, it was just because I got rid of the denominator that it looked a little bit different.
Can you do number 7?
Yeah, let's keep going to number 7. That's a good one. That's also a challenging one. So if we want to know the equation of the line that passes through a point, so we're given a point, so that's good. Oh boy, it's a fractional point, but that's okay. And if we want it to be perpendicular to this line, we need to know what the slope is of this line that we're given so that we can write a slope that's perpendicular. And so what we want to do is start by rewriting 4x minus 8y equals 1. We want to solve for y. So I'm going to subtract the 4x and then divide by minus 8. And so we rewrite it and we get y equals 1/2 x minus 1/8. So and I wanted to do that because I want to know what the slope of that line is. And now I can see the slope. Right? I can very easily see that the slope of this line is 1/2. And that's important because if I want to write a slope that's perpendicular to the slope of 1/2, then I take the negative reciprocal, right? But I needed to know what that slope was so I could take the negative reciprocal of it. Does that make sense? Yeah.
How'd you find that as a slope?
I solved for y, so when I subtracted the 4x over, and then the 4 gets divided by that 8, and it becomes 1/2. And they're both negative. It'll be minus 4 divided by a minus 8, and so you get a positive 1/2 when you do that. Right, so I solved for y. Other questions so far? And so then the idea is we want a line that's perpendicular. So let me write that down. We want a perpendicular line so we take the negative reciprocal. The negative reciprocal means you flip the fraction upside down and also multiply by a negative, right? And so then our slope is m equals -2. Right, we flip 1/2 upside down and multiply by negative, and it becomes 2/1 with a negative. Is that okay so far? So all that was just to figure out what the slope needed to be, because we're only given 1 point, right? We can't calculate slope ourselves because we only have 1 point here, and so we can't use like the slope equation. We needed to do it this way. Let me ask you this before we go on. What if we wanted a slope that was parallel to this line? What would we choose? Yeah, we would just use 1/2. If we wanted a parallel slope to this line, we would just use the same slope. Okay, good. Anyway, we're getting close. So we have the slope. We know that it's going to be y equals mx plus b. And so far we have the slope. So we have y equals -2x plus b. And we need to find b by plugging in the point 1/2 comma -2/3. And so what we have is -2/3 equals -2 times 1/2 plus b. And so now we can solve for b. Right, so we get -2/3 equals -1 plus b. And so that means that b equals -2/3 plus 1. Which is 1/3. And so then we have a slope, we have our slope, we have our intercept of 1/3, and so our final answer then is y equals -2x plus 1/3. So just to summarize again, we needed to figure out what the slope of the original line was so we could find our slope, which was the negative reciprocal. So that's what we did on the left-hand column here. And in the right-hand column, we found the y-intercept by plugging in the point we were given. And that's at least the second time we've done that, maybe I guess the second time. But anytime we want to find the y-intercept, you usually have to plug in a point you're given. And then we put it all together in our final equation. All right, we got 5 minutes left. We can do at least a couple more. Do you have a question about this one now? Yeah, let's do number 5. Other questions about this one, though?
It's kind of the same question I asked about family.
Do you see what I'm saying when I say we want to solve for y in this one?
Would you plug it in as like 0?
No, I want to rewrite this equation as y equals. And so I subtracted the 4 over to the other side. And then, so let me just, I mean, I don't have much room, but let me try to do that. So if I subtract the 4 over, I get that, right? Does that make sense? And then I need to divide by negative 8. So I get y equals minus 4 over minus 8x minus 1 over 8. And so the minus 4 over the minus 8 is the positive 1/2. That's where this came from. Is that clear now? Okay. Alright, let's look at 5. So find the slope and y-intercept of this line. Okay. It's not, we can't find this, well, we could figure out what the y-intercept is right now if we plug in x equals 0, but the slope's not easy to find. And so let's just solve for y again. Because if we solve for y, it'll be in the form of y equals mx plus b, and then we'll be able to just pick the slope and the y-intercept right off of there. And so if I solve for y, we would get minus 2y equals minus 3x plus 12, right? I subtract the 3x over, and then we divide by 2, negative 2, and we'll get 3/2 x minus 6. And so I wanted to do that because now here's my slope, and here's my y-intercept. And so it was real easy to pick those things off of there once we solve for y. And so our slope is 3/2. Our y-int is the point 0, negative 6. And let's use those two things to graph the equation. But at first, is there any questions on how we got those two? Yeah.
How did we get the slope?
I solved for y. So was this part okay where I subtracted the 3x and then I divided by 2? And so now this is in the form of y equals mx plus b, right? This looks like this form now. And whatever's next to the x is the slope, and then whatever the number at the end is the y-intercept. And so that's how I got those two things. The one at the end was minus 6, and then what's next to the x is 3/2. Is that okay? And so if I want to use those two things to graph this, this is a point on the graph. 0, minus 6 is a point, so let's go down to that point. 1, 2, 3, 4, 5, 6. So here's the y-intercept, 0, minus 6. And now I'm going to count the slope off. And so let me count out a couple of numbers here. So I'm going to count the slope off, and it's rise 3, run 2. So I'm going to rise 3, 1, 2, 3. And then I'm going to run 2, 1, 2. And I'll do it one more time. Rise 3, 1, 2, 3, run 2, 1, 2. And so I only needed 2 points, but I just plotted 3 just to make it a little more clear. And now I've got 3 points that I can connect, hopefully, ish. Did an okay job connecting those. And that's my line. Right, but again, that's because we did a rise of 3, and then we did a run of 2. And that's how we got those 2 points. Is that one okay? Which one's on the first page you want to see? Which one, how about? Got time for one more, I'd say. Any of those on the first page? Alright, well for the sake of my video, I'm gonna solve the rest of them. You're welcome to leave. And it's okay, I'm gonna be here talking to myself, but I'm gonna finish this video off and I want to make sure it's complete. Yeah, if you would put the packets up here at the end, if you wouldn't mind. And if you wouldn't mind kind of quietly leaving so I can talk to myself, that would be great. Thank you. Okay, in problem number 1, we're told that we have a slope of 5, and we're given the point 2, 3. And so right off the bat, we have enough information to write the slope-intercept point. I mean the point-slope form, right? Because we have a point and we have an intercept. And so I'm just going to write it in the form that we're given. Y minus y1 equals the slope times x minus x1. And so that's very, very simply the point slope form. If we want the slope intercept form, we have a slope, but we don't quite have the intercept yet. And so we have something that looks like y equals 5x plus b. And now you want to use 2, 3 to find b. And so you plug in the point 2, 3. So 3 equals 5 times 2 plus b. And then we can figure out that b equals 3 minus 10, which is negative 7. And so that means that y equals 5x minus 7 is the slope intercept form. And then for the general form, we just get everything over to one side. So I'm going to subtract everything over to the one side. We get y minus 5x plus 7 equals 0. Right? We just rewrote that one to get the general form. For number 3, to find the point slope form, if we want point slope, we just need a point and a slope. And this one gives us both those things. So this one's very straightforward. The point slope form is just y minus the y value equals the slope times x minus the x value. That one's fairly straightforward. And then the last one, to find intercepts, we find intercepts the same way no matter what we're doing. If we want to find the x-intercept, we let y equal 0 and plug in, or then solve for x. So let's do that one first. So let's let y equal 0. So this is for the x-intercept. We would get minus 3x minus 5 times 0 plus 30 equals 0. And then we solve for x, and we get minus 3x plus 30 equals 0. And so x equals 10. And so we get the y-intercept of 10, 0. We'll be done with this in just 1 second if you have a question. For the y-intercept, we plug in x equals 0. And so for the y-intercept, we get the following. Minus 3 times 0 minus 5y plus 30 equals 0. And when we solve for y, we get y equals 6. And so the y-intercept is 0, 6. And then we're all set.